Hello everybody, here I am again. So let me present you a new solar charge controller, the PWM controller. I just received it from China. It's a pretty generic one. I bought it because it was advertised for charging with 60 amps. So I'm really curious if it's doing this kind of job. Sometimes you need a strong one for doing for charging your batteries just soon as or as quickly as possible. So let's open it up. It's it's a very common box. Inside is the little controller. I had one of these before. It was like I can't remember exactly, 10 or 20 amps. It was doing a pretty decent job. This one was around $12 or something from AliExpress. So as you may see, there are a couple of comments there, and the label, it's saying very clear 60 amps. So the panel should be around maximum 50 volts, 750 watts for 12 volts, or 1500 watts for 24 volts, and delivering out 60 amps. Well, I'm really curious about that. Now I don't have too many panels today, but I have like 650 700 watts power, solar power. So we'll do some tests a little bit later to see if it's really doing the job. Inside the box, it's a booklet with instruction and some technical characteristics, model, and so on. Yeah, the booklet, it's also for different models. I can see here the strongest one is KW1230, 30 amps, and it's nothing about 60 amps they advertise. And anyway, that's the LCD with all the numbers, mambo jumbo, and the menu also, and how you can get into different settings, and also the way the LCD it's displaying different pages. All this menu and settings can be accessed by those four buttons in the front, up and down, and settings, and the power turn off. That's only for the load. We got the connectors. It's pretty strong connectors. I like that. So maybe it's working like they said with 60 amps, and everything it's plastic, or the case it's plastic, and the bottom it's aluminum, and that also work like heat sink. I'm afraid it's not enough. It's a very small plate, aluminum plate, so we'll see later if it's working or not. But for now, let me have some power in the controller to see about menus and all the other stuffs. I also connected a power supply, a 12 volts power supply in instead of a panel for now. I just want to check if the machine is working, and it feels like it's working fine. You see the main screen is there, and it shows that the panel supply with some power to the battery, and the battery is getting charged. I have 11.6 volts. Let me see how many amps we have here. Like I said, it's a lithium battery, so it's not so powerful. Okay, it's charging with almost 500 milliamps. That's pretty okay for now. Like I said, it's a small power supply, 2 amps or something, 12 volts. But this is just for checking the machine. So it's time to open it up. Let's see what's inside there. I'm really curious. So that's the bottom plate I told you. That's aluminum. It's used like a heat sink too. We have 4 screws, nothing special. Use a Phillips screwdriver. I'm not sure what number, but anyway, it's working with any kind of small Phillips. Let's take the button off. Yes, here we go. Oh, yes, of course. So we have four power MOSFETs there. Uh, a lot of heat paste. That's good, but I'd prefer to have better heat sink for sure. And let's see what kind of MOSFETs we got there. I don't think it's something special. Oh, it's nothing. Say okay, it's nothing there. So I can say anything about powers or anything else. Unmarked MOSFETs. But from my experience, that I don't think this machine is charging with 60 amps. Well, we'll see later anyway. So it's nothing on the transistors, as you may see. I think two of them it's for charging, and the other ones it's panel in the panel in. Yeah, same story. Nothing there. No ID. You know, if you are skilled with electronics and stuffs like this, then you can try to have some proper MOSFETs, you know, marked and powerful. I'm gonna do that later in a future project. For now, I'm just curious to see what else we got in there. And as I can see from the panel, from the board, I think we have a common plus. Yeah, that's funny because it feels like all the MOSFETs are in parallel somehow. Um, so no, nothing there. But that's together in parallel. It's only the drain. Okay, these two are sure in parallel, two pieces. I think this come from the solar panel, and this one goes to the battery. It's funny. Yeah, they are totally in parallel. Uh-huh, perfect. I suppose so. Okay, so let's take the other stuffs out. Let's take the board out and to see the other side. The same screws. Absolutely the same like we had before. Another 4 screws. Nothing special. Yes, okay, let's see. So I have the USB ports, charging ports on the left, two USB ports. That's pretty nice, but I can't see any kind of fuse. No kind of fuses, in or out. This is really dangerous, because if we are working with 60 amps like they advertise, we really should have some fuses. It's very dangerous to work with this controller, without fuses. So that's why I really recommend you to have some external fuses, from the panel to the charger, and then from the charger to the battery. That's not a joke. With this kind of currents and amps, it's crazy without a fuse. Like I said, it's a common, yeah, it's a common plus. It's a common plus. Yes, you may see it's a common plus configuration. So everything happens on the negative side of the charger. Yeah, yeah. So common plus, and what else to see there? A couple of capacitors, and the MOSFETs are in parallel. I think that one is for the panel. It's from the panel going to power in. The other ones are going to the battery. Okay, nothing special. We have also a buck converter there, and that's it for inside. I'm trying to see what kind of microcontroller we got there, but I can't see anything. The processor, the microprocessor, it's under the LCD, so I'm not sure if it's Novotron or Atmega or ST something. I don't know, but that doesn't really matter because all of them are doing the same job. Uh, that's the buck converter on the left. You can see a coil there. That's for the USB ports. Okay, let's put this little one together, and let's have some tests.
Yeah, it's a really hard winter here. I'm waiting for the sunshine, to start lighting my my panels. I have like 650 watts. It's just a temporary setup. I don't have the full power on the panels. It's 10 o'clock in the morning, so I'm still expecting some more sunshine. But I'm still gaining like 3 amps. You see here. Sorry for the display. Got an accident. 29 watts already. But it's looking like I have to change these wires, because I'm expecting much more current. Yeah, it's almost 11 o'clock in the morning. The sun is shining. You may see this. Now let's see what's happening over here. Oh, so we got 30 amps. We got 30 amps. And this little one is working as it should. For now, I may say it's okay. Let's measure a little bit the temperature. Well, it's pretty cold in here too. It's like 8 degrees. Yeah, so like I said, it's easily taking 30 amps. For now, I have 31 amps even. 32, 33, but it's looking like soon I have to get rid of these wires because they are very, very thin. Let me check the temperature for now. I got 52 degrees, 57 degrees. Celsius. That means 134 Fahrenheit for now. Okay, let's change the wires. Yes, I just get rid of the ampere meter and energy meter and everything. Let me check how many amps do we have now. It's working pretty okay. Okay, there we go. DC. $29.7. Yeah, almost 30 amps. I'm afraid that's the best it can do. But we have to wait a little bit more. Like I said, it's pretty cold in here too. It's like 7 degrees now. 30 degrees here. Let's see the back. It's 77 degrees Celsius, 165 Fahrenheit. Oh man, it's getting really, really hot. Ooh, it smells already. I'm afraid this is too much for the heatsink. $29, 30 amps. I think this is the best it can do. Let's wait a little bit more. So I just put a little fan behind to help a little bit with the heat dissipation. And let's see if we get more amps. Same story, 30 amps. 30 amps. Okay, once more. 30 amps. 30 amps. This is the best it can do. Temperature check again. $70 degrees, 81 degrees Celsius. Even 90. It reaches 100. Okay, this is really crazy. 100 Fahrenheit, 100 Celsius, I'm sorry, 200 and 166. Anyway, it's really, really hot. I'm afraid it needs maybe with a better cooling system it go farther. But I think that's it for now. Somehow it's working. But like I said, it's getting really hot. And the best I could reach is 30 amps. That's not bad, but it's long way from 60 they advertised, and with 40 amps it's getting really hot. -94 degrees. Even with a little fan. No, you can't touch it. You can't touch it. It's so hot. Okay. Thank you for now. I think that's it for this little one. It's no way to have a 60 amp like they advertise. It's probably 30 amps maximum, and I recommend better MOSFETs maybe and better heatsink, but it's working. That's the best point. Thank you for now.